All of the following are application of microwave except which one? So before going to answer this question, just microwave is one of the type of electromagnetic wave which is produced due to the oscillation of electric and the magnetic field. Microwave has a wavelength from 0.3 meter up to 10 raised to minus 4 meter ranges. Alternative A says transmission of a TV signal. The TV signals use the microwave. FM radio broadcasting also use the microwave. Wireless telephone, which we call the mobile phone or cell phone, also use a microwave to transmit messages. And D says the sonar communications of the submarine. Sonar means simply sonar is a sound navigation and ranging. So sound navigation and ranges, this is sound wave. Sound wave is one of the type of the mechanical wave. It's not part of the electromagnetic wave. So microwave is electromagnetic wave. Sonar is a sound wave. So the exceptions of the application of microwave is the sonar communication for submarine. So the correct answer is on alternative D. If a person is diagnosed to have short-sightedness, which of the following solutions are appropriate to correct the defect? So we know that short-sightedness or myopia is an eye defect which near objects has been seen clearly, but the far objects are blurred, cannot be seen clearly. This is because if a person is short-sighted, the light ray from the distant objects or far objects is converged by the eye lenses before reaching retina. So if the light rays is converged before reaching retina, the image formed is not seen clearly or it is blurred. That means to see the clear image, the light rays must be converged completely on retina, exactly on the point of the retina of eye where the image is formed. So to correct the myopia or short-sightedness, we use a diverging lens, which we call the concave lens on the other hand. So this concave lens or diverging lens diverges the light from the distant objects, and the light again converge by the eye lenses and reaches the retina, and exactly they converge at the retina and form the clear image. So the correct answer for this question is we use a diverging lens or a concave lens to refocus the distant objects or far objects at a closer distances. So the correct answer is on alternative B, which says a diverging lens to refocus the distant objects at a closer distances. So to correct the myopia or the short-sightedness, we use the diverging lenses to refocus the distant objects at a closer distance. A pin stands erected 10 cm from a converging mirror, that is a concave mirror of focal length f is 20 cm. Then how far apart the pin and its images are from each other? That means the distance between the object and the image D is how much. So we are going to find the distance between image and the object. If the object is placed between the focal point and the vertex of the mirror, the image formed by the mirror is always erected, magnified, and the virtual image which is created or formed back of the mirror. So the image is magnified, erected, and it's also the virtual images. So then we know that the distance of the virtual image is given by the negative, and the focal length of the concave mirror or converging mirror is positive. So first of all, the object distance is known, which is S or so is 10 cm. The focal length of the mirror is 20 cm. So we know that here. So to solve this question, we have to find the image distances and add the two distance, object distance and the image distance together added, and gives us the separation between the object and the image. So to do this, we use the mirror equation, which says that 1 over the focal length is equals to 1 over the image distance plus 1 over the object distances. So this is the mirror equation that we use to solve the image distances. So 1 over the image distance is equals to, if we rearrange this equation, 1 over the focal length is minus 1 over the object distances. So if we do this calculation exactly, we get that 1 over c is equals to 1 over 20 centimeter minus 1 over 10 centimeter, which gives us directly equal to negative 1 over 20 centimeter. So then the image distance c is equals to minus 20 centimeter. So this minus indicate that the image is virtual. So we have got the distance of the images. This means from the object to the vertex of the mirror or up to the mirror we have 10 centimeter, and we have calculated from the vertex of the mirror up to the image. So distance d is equals to the object distance plus the image distances. The object distance is 10 centimeter plus the image distance we have calculated is 20 centimeter from the mirror. So if we add this number together, we get exactly 30 centimeter. So the distance between the object and the image is 30 centimeter. The correct answer is on alternative B. If the light ray pass from the medium of high refractive index to the medium of the lower refractive indexes, it always bend away from the normal. This is how it is refracted, and this is the angle of transmission or the angle of refraction, and this is the angle of incidences. But if we increase this value of theta, if this theta incident is increased, the bending away from the normal increases, and we reach some angle which is called the critical angle at which the light reflects 90 degrees to the normal. That means when this theta increases and reach some values of theta c or theta critical, where theta incidence reaches some maximum possible value theta critical, the transmitted angle become 90 degrees. So beyond this angle or beyond the critical angle at which the light is reflected 90 degrees to the normal, above the critical angle the light is reflected back internally to the incident medium itself. So this is what we call the phenomena of the total internal reflection of the light. Below the critical angle, the light ray has a possibility to refract in the second medium. So then the angle at which the refraction occur must be that theta always must be less than the critical angles. So in this question the critical angle is given, it is 62.7 degree. So the angle less than this value always makes the light to refract in the second medium. So according to the question, the value which is less than the 62.7 degree in the given alternative is 40 degree. So the correct answer for this question is on alternative B, because the only angle which is less than the critical angle is 40 degree among the given alternative, which makes the incident rays to be refracted in the second medium, not to be reflected back in the first medium itself. So if a lens produces an image which is 4 times larger than the object is, this means that the magnification of the lens is 4, since the image is 4 times greater than the size of the object is, and the distance of this image is 24 centimeters from the lens. Then what is the focal length of these lenses? So to do this equation, we have to use the lens equation, which says that 1 over the focal length is is equals to 1 over the image distance plus 1 over the object distances. So in this case, we don't know the object distance, but we can find it from the definition of the magnification. So magnification is equals to image height divided by the object height, or image distance divided by the object distances. So from this equation, C over so is equals to m. Then we can find so from this equation. So the object distance must be equal to the image distance divided by the magnification, which is 24 centimeter divided by 4. So then exactly we get that the object distance is equals to 24 divided by 4 is 6 centimeter. So if I substitute into the length equation this value, then 1 over f is equals to 1 over c image distance, which is 24 centimeter, plus 1 over 6 centimeter, or the object distances. So if you rearrange this number, exactly we get that the focal length of this lens is equals to directly 4.8 centimeter. So the correct answer is on alternative C. So which of the following activities are possible without electromagnetic radiation? Reading book. So reading book needs always, we need light, we need a visible light. So the visible light is one of the type of the electromagnetic radiation, or one of the spectrum of the electromagnetic radiation. So this is not possible without electromagnetic radiation. Speaking with friend. Speaking with friend means speaking needs the sound wave. We need sound wave, but sound wave is not electromagnetic radiation, it is mechanical wave. So this is possible without electromagnetic radiation. Satellite communication. Satellite communication needs also a microwave, or which we call the long range waves, like radio and TV signals. So these TV signal or radio waves or microwaves are also a kind of, or one of the spectrum of electromagnetic radiation. So it is impossible. Satellite communication is impossible without electromagnetic radiation. This is watching TV program. So TV program needs also electromagnetic radiation, which we call the TV or radio waves, or simply microwaves. It needs a microwave to watch the television. So this is also impossible without electromagnetic radiation. So the only possible activity among the given alternative is on alternative B, which is speaking with a friend do not need electromagnetic radiation. Index of refraction is the measure of how much the light is refracted when it passes from vacuum to a certain medium. So this is defined as, the index of refraction is defined by the speed of light in a vacuum divided by the speed of light in a medium, which is V. So we know that speed of light in vacuum is greater than speed of light in a medium. So when a light passes from vacuum to some medium, it is speed decrease. Always the light refracts. When the medium has a high refractive index, it refracts more. So this means that the speed of light in the vacuum, if this is a vacuum, the speed of light in a vacuum is given by directly the wavelength of the light in a vacuum times the frequency of the light in the vacuum. But if the light enters some medium, the speed of light in a medium is the wavelength of the light in that medium, lambda m, and the frequency of the light in that medium. So V in medium is simply the lambda in that medium times the frequency of the light in that medium. But the wavelength of the light changes, the speed of the lights also change when it's enter the medium. That means the speed gets slower. The light gets slower down in a denser medium when it's passed from the lighter medium, or when it's from the vacuum. But the frequency of the light wave do not change in medium and in vacuum. So frequency in vacuum is directly equal to frequency. In medium, we use directly F. So if we substitute this value in the given equation, N is equals to C over V. C is lambda in vacuum times frequency in vacuum divided by lambda in medium and frequency in medium. So frequency of the light do not change. So this is equals to lambda in vacuum divided by lambda in medium. So the correct answer among the given alternative according to this equation is on alternative D. So refractive index is equal to the ratio of wavelengths in vacuum divided by the wavelengths in the medium. From this diagram, which of the following relations are correct? So we see from this diagram that the light undergoes from the air and enter into the glass and also emerge from the glass into the air again. So we know that the index of refraction of glass is greater than that of the air. Air has an index of refraction of 1, but the glass has almost index of refractions greater than that of the air. So if the light enters the glasses, it always bend toward the normal, and again it bends away from the normal if it is emerge out from the glasses. So this means that we can see angle theta 1 and theta 4 has a relation. So from this diagram we can see that we use a geometry, because this is a geometric optics. Angle theta 2 and theta 3 are the same because they are internal angles simply. If this is the normal and this is also another normal, theta 2 and theta 3 are equal directly from this geometry. And we can say that if this is the angle of the refraction between the glass and the air, this angle become 90 degree minus theta 4. So 90 degree minus theta 4 is this one, because theta 4 plus this angle gives me 90 degree directly. So then from this geometry we can see that if this one is theta 1 angle, this one is theta 1 and this angle is theta 4, but theta 1 and these angles are equal. So directly we can say that theta 1 is equals to, with this angle which we have calculated, 90 degree minus theta 4. Or simply we can say that theta 4 is equals to 90 degree minus theta 1. So the correct relationship among the given alternative is on alternative D, which says theta 1 is directly equal to 90 degree minus theta 4. So the object is placed at the distance d in front of a plane mirror. Then how the image is formed or among the given alternative, which figures indicates the correct answer. So in a plane mirror we know that the image distance and the object distance are equal. That means if the object has a distance d from the mirror, image is also formed at exactly equal distances d at the back of the mirror. But this image is virtual, erected and equal sizes. That means magnification is equals to 1. That means the image distance is equals to the object distance and the image size is equals to the object size. So the plane mirror do not magnify the objects. That is, image is not magnified equal to as a sizes of the object. The distance of the object and images are also equal. So the image formed by the plane mirror is virtual and erected, but the only change that occurs is the image and the objects are laterally inversed or lateral inversion. This means that the right and the lefts are interchanged. So the correct answer which shows this relationship is on alternative B. So which of the following statement is not correct? about the electromagnetic wave. A says electromagnetic waves are produced by accelerating charge in electric and magnetic field. So this is true because electromagnetic wave is the oscillations of electric and the magnetic field. Or if the charge is accelerate in both the electric and magnetic field, it produces an electromagnetic wave. So B says consists of compression and rarefactions. When we come to these terms, the term compression and rarefactions is related with a longitudinal wave. That means if the direction of propagation and the oscillations are collinear with each other, we have a kind of wave which is called longitudinal waves. Compression represent when the wave fronts are very closer to each other, or we have a compression and the place where the wave fronts are far from each other are called the rarefactions. But when we come to the second type of wave, which is the transverse wave, that means the direction of propagation and oscillation of the objects are perpendicular to each other. So we have something like a sinusoidal wave. So in this case we have peak and we have trough or valley. In the cases of longitudinal wave, the place of peak is we have compression and the place of trough we have rarefactions. Rarefactions and compressions are a term related with longitudinal wave, and peak and trough are the term related with the transverse wave. But electromagnetic wave is one of the type of transverse wave. It consists the term like peak and trough, or it has a maximum and the minimum point. Or the term compression and rarefaction has no relation with electromagnetic wave because electromagnetic wave is a transverse wave, do not longitudinal. So this one is not correct about the electromagnetic wave. C says that it can travel in vacuum and a medium. Still this is true, correct. Carries energy and momentum. It is true. But the only not correct answer concerning electromagnetic wave is on alternative B, which is it do not consist compression and rarefaction. Instead, it consists a peak and a trough.